Okay, so we're just going to quick look at the gradient of the line. So when we're looking at the gradients of the line, there's a couple of things that we have to just make sure that we're doing. Let's go. So first thing, the gradient is just your slope, and it will be your rise on your run. Okay, in order to get the rise on the run, you're going to have to form a triangle. It does not matter where you form the triangle, okay? Because if you have a line, if you do the rise and the run here, or if you do the rise and the run there, this might be 1 to 2, but this might be 2 to 4. When you do the rise compared to the run, you are still going to get the same simplified fraction. Now, you can also write it as a ratio, but it's much better if you write it as a fraction, like 1 to 2. This is what you go up, and this is what you go across. So this part here in the ratio is the rise, that one's the run. But normally we don't write it as a fraction. We don't write it as a ratio, we actually write it as a fraction. Put the rise on top and the run on the bottom. With the rise and the run, think of the run, you run along the ground. So that's why the run is along here. And rise, think of the rising sun. The rising sun is where you go up towards the sunshine. Yay. Okay, and running, you run along the ground. Okay, so if you, the other thing you just need to be really mindful of is whether it's going up. If it's going up, it has a positive gradient, but if it's going down, it will have a negative gradient, okay? And just a couple of other things. A slope like that, like a flat slope, the gradient is actually 0. And a vertical slope, so if something's vertical, often you're told that this is undefined, but it's only undefined because it actually has an infinite slope. Because if you think about that, there's some really, really big number, and what you're doing is you're dividing by 0 because there's no run. Yeah, there's no run. Okay, so it's like Spider-Man climbing up a wall. That's the steepest you could possibly get, is your vertical slope. Okay, so let's go back to this one then. We're just going to look at finding the gradient of each of these. So we need to find a triangle. So you find any 2 points. It could be there. See, even if you went here and here, you actually get the same thing. This is 2 and this is 2. So the gradient, also remember the gradient symbol is m. So instead of writing the word gradient, I'm going to write m. M is 2 on 2, which is 1, and it is a positive slope. This one here, the gradient equals 3. Okay, so that'll be 3 and 3. So it's 3 up, 3 across. So the gradient of that line would be 3 on 3, which is 1, which is positive. Can you see that you get the same thing no matter where you draw your triangle? Okay, so next thing. If we look at this one here, see if you go there, you can't really tell what that is. So when you're trying to find the triangle, you need to get a point that actually goes on the grid. So this is 1, 2, 3, 4 here, 1, 2. So the gradient is 4 on 2, which is 2, and that is positive. This one here, go across now. See, that's not going to work. I'll go all the way across here. So it'll be 2, 1, 2, 3, 4, 5. So the gradient here is 2 on 5, and it is positive. This one here, this one's going down. See, for every one you go across, when you're going down like that, that will be a negative slope. So the gradient would be 2 up here, 1, 2, and 1, 2, 3, 4, 5, 6 across. So the gradient is 2 on 6. So it is minus 1 on 3. Okay, so minus 1 on 3. Okay, all right. Now, so that means like this one here, if we go rise on run when we have our point. Now, I just want to show you that what we could do here to actually get that point. See how that is a 2 there? Do you notice the y values are 3 and 1? Okay, so to get the difference between those, you could actually just go 3, positive 3, take away 1, and that would give you the 2. 3 take away 1 is 2. This one here, it goes from 2 to 0, because you see, notice that that is the x values, 2 and 0. So to get that distance, you go 2 minus 0, which is 2. So what that means is, on the bottom here, you get 2 minus 0, which is 2. So you could simply do the difference in the y's over the difference in the x's. And that's 3 minus 1 is 2. 2 minus 0 is 2. So you end up with a gradient of 1. Okay, so that all works really well. And there is actually a formula you could use. And I've made a video on another slide on this. And you just go y2 minus y1 on x2 minus x1. Because if you just do the difference between the x's and the difference between the y's, then you will get the rise on the run. And the beauty of actually using this, I'll just stuck over here and just show you. The beauty of using this, that even if you have 1, 2, 3, 4. So even if you have a slope that's negative, so we'll go 1, 4 and 3, 1. It will pick up the negative component of your slope. So you don't have to think about whether it's negative or positive. So you think about this one. If I'm getting that one there, see that one there would be 4 take away 1. Okay, because the y value there is 1 and 4, and this one is 3 and 1. So if you subtract the y values, it's 4 take away 1. And 4 take away 1 is equal to 3. So the rise there is 1, 2, 3. Okay, if we look along here, where this one is, here, the x values go from 3 to 1. So if you look at that, that's 1, 2. Okay, so if you did the first y value, the first, like that one we did 4 take away 1. If we did 1 take away 3, you actually get minus 2. And you get minus 2 because this is actually going down. Okay, so if you look at this, then that gradient there will equal 3 on minus 2. And it picks up that it is a negative gradient. So, okay, so continuing with this, all right, if we have these values here, so that's minus 3, 2, and this one here is 2 minus 3, then I could actually get the gradient without even worrying about counting the things. Because when I'm getting the rise, if I subtract those, I'm going to do this is y2 and y1. I could use a formula. I could subtract, we go y2 minus y1, that means the second y minus the first y, on x2 minus x1. Because you do the difference in the y's over the difference in the x's. So it'll equal minus 3 minus 2 over the x value, which is 2 minus 3. Minus 3 minus 2 is minus 5. 2 minus 3 is 2 plus 3, which is 5. So the gradient there is actually minus 1, which makes sense. See, that's 5 going downhill, so it is minus 1. Whereas if you look at this one here, for some silly reason they want to do 2.5, you're probably better off actually ignoring that and doing this one, which would be 4 and 1. So the gradient is 4. But if you want to do the 2.5, do the 2.5. So if instead of just looking at the diagram, if I take the coordinates and I go, okay, second y value, which is 0, minus first y value, which is 2, second x value, which is minus 2, minus 2. So you get minus 2 over minus 2 plus 2.5, which is minus 2 over a half, which is minus 2 divided by minus a half, is minus 2 times minus 2 on 1, because remember you flip the fraction and you end up with a gradient of 4, which you notice is what I get. This just means that you can do this without sketching. What I get if I did it from the diagram, negative gradient going down. Okay, so this one here, just going to look at this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 4, 5. Okay, so the gradient there is 5 on 5, which is 1. The gradient here, they'll say it's undefined. but, it's actually an infinite gradient because it's very steep. This one here, we've got 1 over 1, 2, 3, 4, 5, 6, 7, 8. 1 on 8 and positive. Here, the gradient is 0 because it's flat. This one, the gradient is 0 because it's flat. This one, the gradient is infinite, or it'll be undefined, because you can't actually define infinity in a way. You never actually reach infinity, because I can always tell you one more number that is bigger than infinity.